This shows one of the interesting patterns that you can get, XY pattern, with the JDS6600 dual output waveform generator. And in the rest of this video, you'll see some more. This shows a full chart of all the waveforms that the generator can produce and what the limitations are, whether you can adjust duty cycle or frequency or offset on them. This illustrates that you can not change the amplitude of the DC level, but you can change the offset. This shows the Sine C function, which is really a Sin X over X, but it's not really a true Sin X over X, because the next is what Excel spreadsheet shows a Sin X over X looks like. This shows how the different waveforms get affected by the duty cycle. Only these waveforms are the waveforms that get affected by the duty cycle function. So I have one channel very slightly off, 0.05 Hertz different from the other, so that you can see the many different phase effects of the two waveforms against each other. So there's a sine wave on both channels, and if I go to XY mode, you will see an oval changing to a circle and turn into an oval turning the other way as the sine waves pass between one another. Next we'll try with a triangle. Here's the triangle waveform passing by, and here is the XY format. Sort of reminds me of Twilight Zone. Now I'm going to illustrate that the noise waveform is really a pseudo-random waveform. And I don't know if you can see in there, but it is a fixed pattern, and there it is passing by the triangle. It is not a totally random waveform. It is pseudo-random. It looks kind of random, but it's called pseudo-random. Then probably the most interesting waveform is the multi-tone waveform. So there's the multi-tone waveform moving with respect to itself, and here is what you get with the XY. Notice that the loop is moving from the top to the bottom, and then it goes back around and the loops start going back into the top. Just can keep watching it and watching it. Finally, this illustrates how the frequency counter works. Set up this strange frequency 1, 2, 3, 4, 5, 6, 7, 8.9, and it will show up when I connect it back to the input as the correct frequency. All those digits of accuracy.